There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super-smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super-advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development. So improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. Even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lyton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has two other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody?
Picture this. We finally make contact with aliens. Exciting, isn't it? But then comes the big question, how do you even start a conversation with beings who might be as different from us as apples are from algebra? Enter Olaf Witkowski with an idea that's, well, pretty out there. He thinks the best way to say hello to extraterrestrials is to threaten them. Here's his reasoning. No matter what kind of alien life form we're dealing with, whether those are slimy space blobs or super advanced warriors, there's one universal trait all life shares: the will to survive. It's the basic definition of life itself. His idea is to make them feel like their survival is under threat because, as he puts it, they'll understand that. Essentially, it's like tapping on a fish tank to see if the fish are awake, except these fish might be armed with laser beams. But hold on, this idea isn't about actually hurting anyone. Witkowski's whole point is that survival is a language that surpasses biology or culture. If aliens perceive us as a threat, it might actually open the door to showing them we're capable of cooperation too. Once we've got their attention, we might even find common ground in the basic instinct to stay alive. Sounds like nihilism to me. But before you start picturing Witkowski as some kind of evil sci-fi villain, let's clear that up. He's anything but. Think of him more like a philosopher meets scientist. Calm, introspective, and all about exploring ways to create understanding. He's traveled the world, mastered about a dozen languages, and dedicated his career to studying how AI systems cooperate. If anyone's got a shot at cracking the code of alien communication, it's this guy. Still, not everyone's convinced by his poke the aliens approach. For decades, scientists have been discussing the theory that math and physics could act as a universal language. The idea is that if we beam a signal containing something like prime numbers, the aliens would recognize it as intelligent. After all, a prime number is a prime number, whether you're in the Milky Way or Andromeda, right? Well, perhaps not. Carl Sagan, an American astronomer and planetary scientist, once tested this idea by handing a coded message to talented scientists at a party and asking them to decode it. Spoiler, they failed. And if humans can't crack a supposedly universal message, what makes us think aliens would? Then there's the old debate about whether we should even want to meet extraterrestrials in the first place. Many SETI aka Search for Extraterrestrial Intelligence researchers are optimistic, arguing that any civilization advanced enough to travel between stars must also be peaceful. After all, they'd need to have avoided destroying themselves to reach that point. Plus, let's face it, Earth probably doesn't have anything they can't find somewhere else in the galaxy. Mining our planet for resources when there are countless uninhabited planets out there just seems like bad economics. But not everyone's so sure. Some argue that the galaxy might still be a survival of the fittest kind of place, where the most aggressive civilizations end up on top. Even if most aliens are peaceful, who's to say there aren't a few space pirates out there looking for trouble? On the other hand, what if aliens aren't here to conquer us, but to study us? Maybe their way of reaching out is by testing our survival instincts, kind of like saying, hey, let's see what you're made of. To them, it might not seem hostile at all, a version of a handshake, even if it feels like a punch to us. So what do we do if that day ever comes? There's no perfect answer. Some scientists will keep sending out math problems into space hoping for a friendly reply. Others might be more open to riskier strategies like survival-based mind games. Either way, first contact is bound to be a scenario unlike anything we've ever faced. And if you were in charge, would you try Witkowski's approach and poke the alien bear to start a conversation? Or would you play it safe and hope they send us a "we come in peace" message first?
Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaitre constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaitre constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning. just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between. And these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology, which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2, but if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem. We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely, it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space, much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light-years long, which is like the length of 2 Milky Ways. Turns out, one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name, Planet 9, in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our Sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found two supermassive structures called the Fermi bubbles and Rosetta bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of two or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else, the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare, massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby, so what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and a billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the Sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the Sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the Sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the Sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path to our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. Now, get this. Octopuses are visitors from outer space. Here's how this would have happened. Ice-kept eggs of octopuses stuck in spatial bodies crashed into Earth. Then these guys would have mixed together with a pre-existing set of genetic information available on our planet. And presto, octopuses were born. Well, it may be a long stretch to justify that the highly intelligent octopuses are extraterrestrial beings. But the idea is based on a theory that has been around since ancient Greece, something known as panspermia. Now, panspermia is a hypothesis that says life exists all around the universe, not only in planets. So, things such as space dust, asteroids, and even spacecraft have their share of life glued to them. And when they travel across the galaxy, life is disseminated. This strand of thought has been polemic, since it goes against the idea that all life originated right here on our planet. But as much as this new octopus theory might be refreshing, it doesn't contribute too substantially to the search for life on other planets. It's just too hypothetical. Now, octopuses are in fact incredibly old. The oldest known fossil belongs to an animal that lived almost 300 million years ago. FYI, this is before our dinosaur buddies roamed the Earth. Wait, there's more! Octopus arms have a mind of their own. That's because 2/3 of their neurons lie in their arms, not in their heads. This means that their arms can problem-solve how to open a shellfish, while their owner is worried about other stuff entirely. Talk about ninja-level multitasking. Oh, and like other animals, such as chimpanzees and dolphins, octopuses have proven to be good at maneuvering tools, like picking up old shells and using them as a temporary home. Now, of course, the most intelligent animals on our planet are humans, according to humans. But we don't seem to give pigs enough credit. Pigs are so smart they can play video games. No, not Minecraft. But in a recent academic study, scientists had 4 pigs play a joystick game. They had to manipulate the stick so that the moving ball would hit the wall and then they would get a treat. All 4 pigs did great in the test, which was surprising even to the scientists. Now, pigeons also aced an impressive test. They were trained to differentiate a Picasso painting from a Monet one, which they had no trouble learning. Then they were able to apply this knowledge, identifying works of art they had not previously seen, meaning they really understood the difference between each painter. Poor things are always seen as a nuisance. Now, if we placed kangaroos in an Animal's Most Amazing Ability contest, they'd win. It's mainly because they break the four-legged rule. A special species of kangaroo, the red kangaroo, uses its tail to help propel it forward. Now, visually, it has 4 limbs, but in practice, it uses 5. They're biologically built to use their tail as a 5th limb, since it's packed with articulated vertebrae and thick muscles. Of course, it had to be an Australian animal. Okay, jokes aside, Australia is home to a variety of unique animals, like the most venomous snake in the world. This not-so-cute reptile is known as the inland taipan, and its venom is enough to take down 100 humans. And still, on the topic of dangerous animals, the island is also home to one of the world's most venomous spiders, the funnel web spider, which can be found not too far away from downtown Sydney. Yikes! The Little Mermaid may have shown us that life is good under the sea, but she didn't mention anything about the bizarre ways of the anglerfish. Anglerfish are those special types of fish that have a huge whip nose connected to the front part of their bodies. They look like they're forever holding a lantern in front of them, except that the little lantern they carry is a type of bioluminescence, and is far from romantic, as anglerfish use it to lure smaller fish in as their meals. It was back in 1999 that scientists discovered that these little guys spend most of their lives upside down. They had never seen anything like that. Hovering above the Pacific Ocean floor at a depth of around 16,400 feet, where light almost doesn't even reach, there they were. They do this because since they live so close to the seafloor, their built-in lantern illuminates the ground in search of food. They might be weird, but they're also pretty clever. Recently, scientists have discovered a species of animal that has neither a brain nor a head and is pretty smart. Meet the brittle star. This 5-armed creature is a bundle of nerves, and it has proved itself to be super clever. In a recent experiment, scientists would dim the light while they fed brittle stars their favorite treat, yummy shrimps. After 10 months of conditioning, these babies would creep out of hiding as soon as the scientists turned off the light in the room they were in. Surely they were expecting to enjoy a delicious meal. Now, we really shouldn't judge a brain by its size, or lack of brain in this case. There's something known as the orange cat behavior, and apparently it's not just a meme. So far, scientists have been able to understand that coat color is connected to a feline's gender. And since orange is an X chromosome, orange cats are usually males, like Garfield. The so-called orange cat behavior describes ginger cats as agents of chaos. Again, pretty much like Garfield. However, there haven't been any conclusive studies on whether coat color and cat behavior are truly linked. In terms of vision, mantis shrimps probably have the most psychedelic vision out of all animals. These funny-looking creatures have a whopping 16 varieties of photoreceptors, with 5 of them reserved for the ultraviolet or UV spectrum. Ultraviolet rays are really short wavelengths, which are invisible to humans. The thing science still doesn't understand is how exactly these mantis shrimp view the world around them. Sure, they can perceive a bunch of colors, but they can't necessarily distinguish all of these colors among themselves. It can be that they just see a lot of really vivid, really blurry colors, but we haven't figured out a way to check that out. Now, to say sloths are cute is an understatement. They may be one of the friendliest animals in the jungle, but there's more. If you look closely at their fur coat, you'll notice hints of green. These greeneries are actually tiny little algae that grow alongside sloths. They help sloths to camouflage better in the jungle, but they also nurture them. The little cracks inside a sloth's fur create the perfect environment for algae reproduction, and scientists have found species of algae that don't exist anywhere else in the world. They do get by with a little help from their friends. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey. Now meet this guy. Unlike what its name might suggest, the red panda is closer to a raccoon than it is to a giant panda. You'll find a lot of these cat-sized creatures in the Himalayan region, hopping from tree to tree and bundled together trying to keep warm in the harsh weather. They're gentle and friendly like their big panda cousins, and occasionally enjoy eating some bamboo sticks. And then there are bees. Compared to humans, bees' brains are the size of pinheads, yet they are capable of astounding things. Let's say a bee is running low on energy after a long search flight. This bee desperately needs a drop of honey in order to continue flying, but smartly enough, she doesn't need to go back to the hive to recharge. She can ask a fellow beehive mate for a drop of honey directly from this other bee's stomach and continue flying. This type of decentralized system allows them to build highly effective societies, one that bees don't need to push to the queues in front of the honey cells, for example. Hey, just kidding.
It is assumed that there is a supermassive black hole at the center of every galaxy in our universe. These space monsters have been discovered in the centers of many galaxies, and our Milky Way is no exception. There is Sagittarius A at its center, a supermassive black hole surrounded by a hot, radio-emitting, accreting gas cloud. To accrete means to absorb matter from the surrounding space under the influence of gravitational forces. In the case of black holes, the attraction is incredibly strong. As a result, the radiation surrounding them is also immensely powerful. Observations made by the Event Horizon Telescope in 2022 made it possible to simulate this substance in our galaxy. From these observations, astronomers were able to estimate the mass of the black hole. It turned out to be 1 million solar masses, which is about 1 million times less than the mass of the entire Milky Way galaxy. So, 1/1,000,000th of the mass of our galaxy is that supermassive black hole at its center. Such a ratio of the mass of the entire galaxy to the mass of the black hole at its center is characteristic of many observations. Moreover, the value of this ratio is reproduced within the framework of modern models. Now, let's discuss two hypotheses for the formation of supermassive black holes. The first model speaks about the creation of small seeds that describe the gradual increase in the mass of a black hole, the accretion of matter into a stellar mass black hole. The second model suggests that supermassive black holes form when large gas clouds collapse. In this case, the collapse occurs bypassing the stage of a supernova explosion, in which the explosion would scatter most of the mass, preventing the formation of a supermassive black hole. In any case, conceptually, such a process can be described this way. There's matter in some compact area, which is the seed for the growth and development of a black hole. Black holes accrete matter around them and their mass increases. It is important that the evolution of black holes is a temporary process that scientists want to study in dynamics. But how can one see evolution that takes place over millions or even billions of years? Unfortunately, or fortunately, light from a distant galaxy takes time to reach us. That's why if we look at very distant objects, we will see them as they were in the past due to the propagation delay of light. But to look far into the past, one needs to look at very distant objects. The light from them is very difficult to observe experimentally. The good news is that with the launch of the ultra-precise James Webb Space Telescope, scientists can study even faint signals from galaxies that formed when the universe was about 1 billion years old. That is, looking back almost 14 billion years. One of the most surprising results obtained from James Webb is the discovery of a lot of galaxies within 2 billion years of life of the universe. These galaxies have active galactic nuclei, faint compact regions at the centers of galaxies, emitting large amounts of energy. Here, the Space Telescope shows its power. These active galactic nuclei have luminosity that are thousands of times lower than the luminosity of quasars detected in ground-based studies. They appear red because they are dusty. The dust obscures black holes and reddens the colors, so they're called little red dots. What is very important, their masses lie between 10 and 100 million solar masses. Surprisingly, using very advanced analysis methods, scientists can estimate the mass of a black hole at the center of a little red dot. It turns out that it reaches millions of solar masses. It means that the mass of a black hole at the center of such a little red dot is only several orders of magnitude less than the mass of an entire galaxy. I'll remind you that the supermassive hole at the center of our galaxy is millions of times smaller than the mass of the entire universe. Thus, the ratio of the mass of supermassive black holes at the centers of such galaxies to the mass of the entire galaxy is phenomenally large. But explaining this fact will be a difficult problem for current models of black hole evolution. One of the hypotheses that scientists are now working on is that it's not a black hole that forms from a seed at the center of a galaxy, as we discussed earlier. It's a galaxy that forms around the already created black hole. Such black holes are called primordial black holes. This is a hypothetical type of black hole that was formed not due to the gravitational collapse of a large star, but in superdense matter during the initial expansion of the universe. If it turns out that these primordial black holes do exist, it will open up a new window for dark matter models. But this is a topic for another video. Recently, an international team of astronomers has used the James Webb Space Telescope to find evidence for an ongoing merger of two galaxies and their massive black holes, and it happened when the universe was a mere 740 million years old. The double black hole system is known as ZS7. This is the most distant detection of a black hole merger ever. Plus, it's the first instance of such a phenomenon detected so early in the universe. But let's look into the details. Astronomers have been locating different supermassive black holes with masses of millions to billions of times the mass of the Sun, situated in the most massive galaxies in the local universe, including our home Milky Way galaxy. Those giant black holes most likely had an immense impact on the evolution of the galaxies where they dwell. At the same time, scientists don't fully understand how those objects got to be so massive. The discovery of such monstrous, fully formed black holes means that their growth occurred very quickly and very early. Massive black holes that are actively accreting matter have special features that allow astronomers to detect them. These features are usually not visible from the ground, but can be observed with the help of James Webb. So, researchers found evidence for very dense gas clouds with rapid motions close to the resulting giant black hole. Plus, they detected hot and highly ionized gas, illuminated by energetic radiation, like the one typically produced by black holes in their accretion periods. With the incredible sharpness of the telescope's imaging capabilities, scientists also managed to spatially separate the two black holes. One of these holes has a mass that is 50 million times the mass of the Sun. The mass of the other black hole is likely to be similar, but it's much more difficult to measure it since this second hole is surrounded by a thick cloud of gas. These findings suggest that mergers are a crucial way through which black holes can grow extremely fast, and they could do it already at cosmic dawn. After analyzing other Webb's findings of active massive black holes in the distant universe, researchers have come to the conclusion that massive black holes have been influencing the evolution of galaxies from the very beginning. Once the two black holes merge completely, they will also generate gravitational waves. Such events are supposed to be detected by the next generation of gravitational wave observatories, such as the upcoming Laser Interferometer Space Antenna, aka LISA, mission. It has been recently approved by the European Space Agency. This mission will be the first space-based observatory dedicated to studying gravitational waves. The results we get from James Webb tell us that lighter systems detectable by LISA might be more frequent than we used to think. It will likely make researchers adjust their models for LISA rates in a similar mass range. Currently, astronomers are planning to study in detail the relationship between massive black holes and their host galaxies in the first billion years. An important part of this program is systematic search for and characterization of black hole mergers. It will help us determine the rate at which black hole merging occurs in the early universe. Plus, with the help of this research, we can figure out the rate at which gravitational waves have been produced from the dawn of time.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
You're traveling through deep space, circling stars and entire galaxies. Whoa, looks like this multicolored nebula will soon collapse under its own weight and explode like a supernova. Now let's carefully circle this black hole. Try not to get caught in its gravitational field, or it'll swallow you like a space monster. Wait, what's that strange structure right there? It's a glowing wall. And if you look closely, each glowing dot is an entire galaxy. That wall has about 100,000 of these galaxies. The Milky Way has 100 billion stars. So this wall holds a quadrillion, that's 10 followed by 15 zeros, of stars like our sun. This giant structure is called the South Pole Wall. It's located about 500 million light years from Earth. By comparison, the closest star to our home is Proxima Centauri, and it's about 4.2 light years away. Rockets can cover that distance in about 73,000 years. So the journey to the South Pole Wall may take longer than our solar system exists. And this wall is simply gigantic, even on a cosmic scale. It's about 1.37 billion light years long. To give you an idea of how large that is, the Milky Way is only 100,000 light years wide. But you can't see this wall even with the most powerful telescope. The problem is that the Milky Way itself obstructs your view. It's so bright that it's hiding this wall. It's like trying to look at the starry sky in a metropolis. The light pollution won't let you do that. Scientists have been able to detect this galactic wall by measuring redshift. We know that all objects in the universe are moving. They spread out from each other as a result of the Big Bang, which happened billions of years ago. And when galaxies move, their light waves change slightly. By measuring this change, we can understand what the object is and how it moves. And this wall isn't even the largest in our universe. This is the Hercules Corona Borealis Great Wall. It's a giant flat superstructure about 10 billion light years wide. That's around 10% of the entire observable universe. And it's also a wall. That is, a cluster of galaxies. We were able to detect this giant structure by gamma ray bursts. It's the brightest electromagnetic event in the universe. You could even see it in the far reaches of our universe. Such bursts are a very rare event. In the Milky Way, for example, it happens once every few million years. If we notice many such bursts in a short time from the same place, it means that there are many objects like the Milky Way in that place. So, there are a lot of galaxies out there. Another unusual giant structure in the universe is the huge, large quasar group. It's about 4 billion light years across. So it takes a photon of light almost as long as our planet has existed just to get from one side of the structure to the other. And if you put the huge, large quasar group on the scale, it would be 6.1 billion times heavier than our sun. Scientists have found that there are at least 73 quasars in that structure. These are some of the most unusual objects in the universe. They are the active cores of galaxies. At the center of a quasar is a supermassive black hole. This giant eats up the matter around it. A wild force of gravity twists the matter around the black hole, forming a disk. And this disk is the source of the strongest radiation out there. By comparison, the radiation from a single quasar is tens or hundreds of times stronger than that of all the stars in our galaxy put together. Because of such strong radiation, we can detect quasars, even at very long distances. That's why they're also called beacons of the universe. Scientists use quasars to study the universe and the movement within it. One of the most distant quasars from us is about 13.1 billion light years away. This makes it one of the oldest objects in the universe. It appeared about 690 million years after the Big Bang, and it's almost 3 times older than our solar system. It's still glowing with extreme brightness, about 4 and 14 zeros times brighter than the sun. Scientists explain that at the center of the giant is a supermassive black hole, 800 million times heavier than the sun. All these giant structures are just building blocks of our universe. Look, this is our solar system. Now, zoom out a little, and this is where our home star is in the Milky Way galaxy. Zoom out again. Here's a local group of galaxies. All the bright spots here are galaxies. Here's Andromeda, and here's the Triangulum galaxy, plus a few dozen other slightly smaller galaxies. They're all gravitationally connected. The size of this structure is about 10 million light years. That's 100 times the width of our galaxy. Zoom out, please. This one is the Virgo supercluster. It's 20 times larger than the local group. There are about 30,000 different galaxies, and the mass of the whole thing is about 1 in 15 zeros solar masses. Zoom out again. Laniakea. This structure is almost 3 times larger. It includes the Virgo supercluster and other smaller clusters. And there are about 100,000 galaxies here. It's not over yet. Zoom out one more time. Here's the Pisces Cetus supercluster complex. This giant galactic structure contains about 60 clusters of galaxies. So there are more galaxies in it than grains of sand in the desert. You know what to do. Zoom out! Phew, this is the observable universe. There are over 500 billion galaxies. And the stars? Well, there are about 1 billion trillion stars. the observable universe has its own structure. Clusters of galaxies form chains and walls, as you've seen before. But these strands are separated by huge regions of absolute emptiness. These areas are called voids. In these places, there is no matter at all. There are fewer molecules in the voids than in an empty room. One of these voids has a very mystical reputation. It's the Eridanus supervoid, or the cold spot. It appeared here only 380,000 years after the Big Bang. It's almost 1 billion light-years wide and could hold hundreds or thousands of galaxies with trillions of stars. Some scientists believe that this cold spot may have been the result of the largest collision ever, a collision of universes. There's a theory that our universe is some kind of bubble, a huge sphere that contains all these walls and chains of galaxies. Now imagine that there's an infinite number of these bubbles. They could be parallel worlds or different universes. Many years ago, one bubble came close to the bubble of our universe. Their walls touched, and the two universes connected for a while. It's like two drops of water coming together. But that universe kept moving. The area where the bubbles joined became thinner and thinner until that connection broke, and the two bubbles detached from each other. At this point, the second universe ripped some of the material out of our bubble. All those galaxies that used to fill the Eridanus supervoid ended up in a parallel universe. Scientists supposed we might travel through other bubbles. Flying to the supposed wall of our universe would take forever, and then it would take even longer to fly through interuniversal space. So we have to use portals, or wormholes. Here's how it works. Imagine a piece of paper with point A on one side and point B on the other. Instead of moving all the way across the sheet of paper, we just fold the sheet so that point A is right above point B. All that's left to do is make a small hole, and the journey takes only moments. Some scientists believe that such shortcuts through universes lie inside black holes. But how do you survive falling into a black hole? You just have to pick one that's big enough. It's all about gravity. Imagine you're falling into a black hole right now. The closer you get to it, the stronger effect it has on you. It intensifies with every inch. At one point, the gravitational force that affects your head is much stronger than the one that affects your feet. Then you turn into spaghetti. Yum. But if you choose a supermassive black hole, like the ones at the centers of galaxies, the gravitational force in them increases gradually. They can be millions of times heavier than the sun and much bigger, but the gravitational force on your head and your feet will be almost equal, and you will still feel comfortable. Who knows? Maybe if you manage to survive a fall into such a massive black hole, you'd find yourself in a completely different universe where different laws of physics apply. But so far, this is just a theory.
Have you ever heard about the Big Bang? I bet you have. So the history of the universe and its evolution is widely known as the Big Bang model. It claims that our universe began as an insanely hot and dense speck about 13.7 billion years ago. But how did it go all the way from a tiny point to the ginormous world we see and don't see today? We're about to figure that out. Despite its name, the Big Bang wasn't a powerful space explosion. It was the appearance of space everywhere in the universe at once. And the universe itself was born as a very dense single spot in space. No one knows for sure what was before this moment, but scientists are working on figuring it out. Their main assistant is the cosmic microwave background, which still contains the afterglow of the radiation and light left after the Big Bang. Eventually, it may help scientists piece together some clues about the early universe. Just like any kid, when the universe was very young, about 1/100th of a billionth of a trillionth of a trillionth of a second, it experienced an unbelievable growth spurt. Known as inflation, this burst allowed the universe to double in size at least 90 times. As the universe was expanding, it was also getting cooler and less dense. After the insane growth burst, it kept growing, but at a much slower rate. Very soon, the universe cooled down enough for matter to start forming. Everything happened so fast at that time. Light chemical elements appeared within the first 3 minutes after the formation of the universe. Protons and neutrons began to collide, producing deuterium, an isotope of hydrogen. A lot of this deuterium combined and created helium. Then, the process is slowed down significantly, but still for the first 380,000 years after the Big Bang, the intense heat from the creation of the universe made it too hot even for light to shine. The conditions in this early universe were hellish. Atoms collided with such force that they broke into an opaque plasma of electrons, protons, and neutrons. This dense veil scattered light like fog. But 380,000 years after the Big Bang, the matter eventually cooled down enough for electrons to connect with nuclei and form neutral atoms. This absorption of free electrons finally made the universe transparent. By the way, the light unleashed at that time can still be detected today in the form of radiation. A period of darkness followed this era called the Era of Recombination. And then, stars and other bright objects started to form. It happened about 400 million years after the Big Bang. This next period got the name reionization. Some time ago, scientists thought that it had lasted more than 500 million years, but new evidence hints that it might have occurred more rapidly than we thought. During this period, clumps of gas collided and created the first galaxies and stars. These events emitted ultraviolet light, which got rid of most of the surrounding neutral hydrogen gas. That's why we call those times the period of reionization. This process led to the universe becoming transparent to ultraviolet light for the first time. At the moment, astronomers are combing the universe in search of the farthest and oldest galaxies. Such a discovery can help us understand the properties of the early universe. It's like working backwards to piece together the events that happened before. That's what researchers are doing now by studying the cosmic microwave background. Our solar system was born around 9 billion years after the Big Bang, which makes it around 4.6 billion years old. As far as we know, our Sun, orbiting approximately 25,000 light-years from the galactic center, is one of more than 100 billion stars in our home Milky Way galaxy. The most popular idea is that the Sun, as well as the rest of our solar system, was once formed from a huge rotating cloud of space dust and gas known as a nebula. At one point, gravity caused this nebula to collapse. It started spinning faster and, eventually, flattened into a disk. Most of the material that made up the nebula got pulled towards the center of this formation, and that's how the Sun was born. At one point, scientists started thinking that there might be more mass in the universe than what we see. After some research, the concept of dark matter appeared. One theory stated that this mysterious stuff could be formed by some exotic particles. They don't interact with regular matter or light. That's why it's so difficult to detect them. Already in the 1920s, astronomers made an astounding discovery. Apparently, the universe isn't static. It's constantly expanding. Interestingly, when decades later, in 1998, the Hubble Space Telescope studied distant supernova, it became obvious that in the past, the universe was expanding more slowly than today. Why was this discovery so confusing? Because it was long believed that the gravity of matter making up the universe would slow down the expansion process, or even cause the universe to contract. That's why these days the concept has changed a bit. Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant that there had to be some enigmatic force counteracting gravity. It got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. And still, Even though nowadays we know much more about the universe than we used to, there are still important questions that remain unanswered. And, of course, dark matter and dark energy remain the biggest mysteries. Another one is whether something existed before the universe was born, or maybe the theory of the false vacuum is correct. It says that our universe exists in a false phase state, which means it's just a temporary thing. What's more, it's only part of a larger universe. If you compare this larger universe with a kettle full of boiling water, the universe we live in will be just a tiny bubble on the surface of the water. But this can't keep going endlessly. One day, perhaps in billions of years, this false vacuum will burst. And then the visible universe around us will instantly vanish with a pop. There won't be any preliminary warning, and we'll have to somehow deal with it. In any case, astronomers are working hard to find the answers to these burning questions. The James Webb Telescope, launched in 2021, is believed to be the very tool that can help us to peer back to the beginning of time and explore the evolution of the universe with the help of its infrared instruments. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe.
Empty space is not really empty. At least, that's what quantum field theory says. It's actually filled with tiny vibrations that can turn into virtual particles if they have enough energy. These virtual particles can produce packets of light with low energy called photons. Now, there's something every black hole has: an event horizon. It's a point of no return. That means once something crosses that point, it can never get away. Not even light. And there's an insanely strong gravitational force around the event horizon. Black holes survive by gobbling up gas and stars around them. In most cases, a black hole has a swirling disk of material that surrounds it, called an accretion disk. It glows brightly as all those things that come too close to an event horizon get heated up and torn apart before the black hole swallows them all. As material comes closer, it starts to travel and move faster and faster, going all around the black hole. This makes the accretion disk glow and, at the same time, outlines the shadow of the black hole, which is basically the very event horizon we're talking about. Black holes might even want to hide, but they do so awfully badly. According to Einstein's theory of general relativity, gravity bends and warps space and time. It means that the closer you come to this extremely powerful gravitational pull around the black hole, the more twisted space and time around it become. That's what Stephen Hawking was talking about nearly 50 years ago, and it doesn't stop there. He also suggested that if these particles find a way to escape a black hole, they steal some of its energy. And because of these thieves, the black hole loses its energy as time goes by until it, at one point, completely disappears. He suggested that black holes release energy in the form of thermal energy or heat, which is called Hawking radiation. And this radiation doesn't carry any information. It means that when a black hole evaporates, it destroys all information it had about the star that created the black hole. That way, we can't know what really happened. And it's kinda confusing because the laws of quantum mechanics say the information can't be destroyed. This conflict is something we call the Hawking information paradox. According to Hawking, all this information isn't really lost, but is stored in a cloud of all those zero-energy particles that surround the black hole. He called that soft hair. Now, there's this new study as a possible solution to this paradox. Maybe Hawking radiation is non-thermal. Instead of just releasing plain heat, it's possible the black hole sends out a message in the form of radiation. This message contains important information about the black hole's past, the stars that formed it, and other details we thought were lost forever. It's like a secret code that tells us all about the history of the black hole. But let's go back to Hawking's theory, where a black hole can eventually disappear. It says that not only black holes produce Hawking radiation, any object with enough mass can. Researchers actually studied a process called the Schwinger effect too. It's when an electromagnetic field creates strong distortions and in that way forms matter. They applied this idea to Hawking's theory of black hole radiation. What they found is that the radiation Hawking predicted can actually be created in places with different levels of gravity, not just around black holes. Here's the key. When there are massive objects, like stars or planets, they create a curving effect on space and time. This curving is there because of their strong gravity. Even if you're far away from a black hole, there's still some massive object somewhere around that creates the curving of space, which can make you feel like you're in that twisted space. It can create radiation, similar to what happens near black holes. It means that not only black holes can slowly evaporate, other massive objects in the universe can also lose their energy in the same way. If this is true, the energy of everything in the universe will slowly be drained away in the form of light particles. That means everything and everyone, including stars, planets, black holes, and us, share the same destiny and will all eventually fade away. This sounds scary at first, but even if this theory is true, it's not going to happen anytime soon. It would take way longer than the current age of the universe for a supermassive black hole to completely disappear. So, in the way we measure time, black holes are basically eternal. And stars could last even longer since many black holes formed after some giant star collapsed upon itself. Some others belong to a group called primordial black holes. Hawking, who became famous for talking about black holes, mentioned those ones as well. And the theory says they probably formed spontaneously in the early universe, not long after the Big Bang happened. Hawking realized that primordial black holes could have different sizes, from very light to very heavy. Really small ones would have disappeared by now because of Hawking radiation. There's a pretty cool idea that these primordial black holes could be dark matter. It's a mysterious substance that scientists think exists in the universe. It doesn't give off or reflect light, so we can't see it directly. Scientists think dark matter might explain why stars and galaxies move in strange ways, but we still don't have the tools yet to confirm whether these black holes really exist or if they're actually made up of dark matter or not. Hawking also explored the idea that our universe is just one of many universes. It's a concept called the multiverse. Some scientists believe it could be that any situation you can imagine in your life is happening somewhere in some other universe. Hawking didn't agree with that, so in his final paper, he proposed a new mathematical framework that made the multiverse finite instead of infinite. This means that there would be a limited number of universes rather than an infinite number. Another thing that's hard to test and prove, but at least he left us with something to think about. Believe it or not, time travel is not that impossible according to the laws of physics. Scientists have equations that suggest we could have something called closed time-like curves that might allow us to go back in time. Imagine going back to the most embarrassing moments of your life. Knowing what would happen, you could avoid them. But here's the tricky part. Going back in time could cause some big problems. It could create situations where things would happen in a way that doesn't make sense. Imagine you're walking down the street and meeting your younger or older self, or accidentally changing things that have already happened. Hawking was talking about this part too. And these are all things that made him concerned about time travel. He made a guess called the chronology protection conjecture. He suggested there might be a rule of nature that stops time travel from happening because it could create all these strange and confusing situations where we would just go back, fixing our wrong decisions rather than living in the present. Until we discover traveling through time without causing such disruptions, I guess all we're left with are life lessons and learning from our mistakes. In his last years, Hawking talked about the future of humanity, and we still don't know if he was totally serious. He mentioned a special particle called the Higgs boson that could cause a big bubble that could gobble up and eventually even destroy the universe. He also mentioned things like beings from other planets coming to Earth and conquering us, or robots becoming smart enough to take over the world. Some of his ideas turned out to be true, and time will tell if it will be the same with the others.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the Sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe, but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.